Hey everyone, so today we're going to move on to Unit 9, Day 1, Part 1, okay? And this is basically information we covered back in December, I believe, or maybe it was January. I cannot remember, but I told you, we did a little bit about this because y'all were helping me out with my national boards. So we did this exact lesson, but I'm just going to go over it again in case you forgot about it, okay? And we're going to move forward with the statistics unit, okay? So basically, we're going to be talking about scatter plots. Okay, so a scatter plot is a graph with a lot of points from gathered data. Okay, the correlation and association is basically the pattern or relationship between the x and the y values in a scatter plot. So, what kind of relationship do we have? Is it a positive relationship, a negative relationship, no relationship? Positive correlation, negative correlation, and so on. Okay, is it a linear correlation, a linear association, nonlinear association, and so on? Okay, so if we look at some of the key concepts, so the first one is the types of correlations. So the word correlation and association are basically the same thing, so you can use either or interchangeably. So if we look at the scatter plot all the way on the left, we consider that to be a positive correlation because the idea behind scatter plots is that you're looking at the overall picture. And I know in the past, when we talked about linear functions, we would basically connect dots to make a straight line, and every single dot will be on that straight line, and that will make that linear function. With scatter plots, we're looking at the overall picture, okay? So, based on looking at the points, you can tell that it's going in a positive direction, okay? So, we know this is known as a positive correlation. And of course, you're also welcome to draw a line. So basically draw a line that follows the pattern of the scatter plot. So for this example, if you follow the pattern of this line or of the scatter plot, you will see that we can make a straight line that goes in a positive direction. So we know this is a positive correlation. Now, if we do the graph all the way on the right, you will notice that the points on the scatter plot are going in a decreasing form. So this is known as a negative correlation. And of course, you can draw a line that follows the pattern of the dots, and you would see that it's headed in a negative direction. And then, of course, the graph, the scatter plot in the middle is known as a no correlation, because there's no pattern, there's no relationship. You can't go in an increasing form, you're not going in a decreasing form. It's just all random. It looks like I grabbed a bag of marbles and just threw it on the floor, and they went everywhere. Okay? Then the next type of thing we're going to talk about is linear association versus non-linear. So basically, linear is, let me see. So for this one, you can just draw yourself a scatter plot with a whole bunch of points going up. Now, of course, remember with scatter plots, we're looking at the overall picture. And I know I've said in the past with linear functions, all of our points will make a linear line, and therefore it will be linear function. But with scatter plots, we're looking at the overall picture. So here, this clearly it's headed in a in a linear form. Okay. Yes, you might say, well, Mr. Gomez, this line is not touching most of those points, so how can it be linear? You are correct. It is not a perfect linear as to what we're used to from our unit linear functions. This is just a linear association. There's a linear pattern, okay? The dots are going in a linear form. Now, the next type of association, okay, and let's go ahead and write linear association for this. The next type of scatter plot that we may have is the nonlinear, okay? And nonlinear basically means that the pattern of the scatter plot is headed in a nonlinear form. So in other words, it's curving. it's turning, something like that. It's not headed in a linear format. Okay, so an example will be something like this. Eventually, if you follow the dots, okay, you're gonna notice that it basically curves. Okay, so the pattern itself is curving, so therefore we know that as a non-linear association versus over here, which is linear association. And then, of course, the last one is just going to be no association. So that's basically random points everywhere, which we also know it as no correlation. Okay, there's no pattern. It's not curving. It's not going in a linear direction. None of that. So we will consider that to be no association. Or you could just say no correlation. Okay? Now, just to show you a few examples, this is from 8th grade math. They do talk about this, okay? You notice here, this scatter plot is headed in a linear format, so that's why we call that linear. And then, of course, we have nonlinear. If you notice, the points on the scatter plot are curving the pattern itself. So therefore, we consider that to be nonlinear, okay? Now, this is the hardest part for some of you is because we're used to linear functions where, every single dot that we connected, will make that straight line. And that's what we call perfect, perfect linear function. Okay, it's perfect. Every single dot um, forms the straight line. But with scatter plots, once again, we're just looking at the overall picture. We're looking at the pattern of the scatter plot. This is a pattern that's going in a linear format. This pattern is going in a nonlinear format. Okay, let's move on. The next thing we're going to have is strong negative versus low negative, and then strong positive versus weak positive, and so on. Okay, so strong positive basically will be a strong negative. A strong negative would basically mean that the scatter plot is decreasing. Okay, but the dots are really really close to each other. Okay, very close to each other that they almost make that perfect straight line. Okay, but not quite. So their correlation is very strong versus something that has a weak negative. It's still decreasing, but the correlation is a little bit weaker. The dots are a little bit further apart from each other, okay? But they're still going in a negative direction, okay? So you see the difference? Over here we have a strong negative. The dots are closer to each other. They're almost making that perfect straight line that is going in a negative direction. However, over here, still going in a linear format. The only difference is that the dots are a little bit further apart. Okay. Now, same idea here. Strong positive, also known as high positive, is just the same thing as a strong negative. The only difference is that it's increasing. So my dots are still really close to each other, almost forming that perfect, correlation where the correlation is really, really strong. Okay. Versus over here where we have weak positive, also known as low positive, where it's still going in a positive direction, but the correlation itself is a little bit weaker. Yeah, we can see that it's a positive correlation, but the correlation or the relationship, it's a little bit weaker than something over here where it's a little bit stronger. Okay? So that's the difference between, strong negative, low negative, and then strong positive, low positive. Okay? And then the last thing we're going to talk about is, discovery question number 2. It says the table represents the scores of students studying for different amount of times. Part A, use the given table to construct a scatter plot in the grid below. So, and label the graph with appropriate scales and titles. So what I did it right here on the x-axis, that is the number of hours studied. So number of hours studied, okay? Based on the chart. Okay, and then on the y-axis, that's known that is the score, their test scores. Okay, so here we go. Oh, and if you notice, I went by halves or almost halves. Okay, so I did one, 1.5, two. So every 2 blocks was a whole unit. Okay, and then here I started at 45 and went up by fives. And the reason I did it like that is so I can be able to fit in all the points, and so I can get a clear picture. So after that, I went ahead and took a moment and plotted each point or each data point. Okay, 258, 258 is right there roughly. And so, anyways, it creates that scatter plot. So, part B is the relationship between the studies and the scores and the study hours linear or non-linear. Clearly, this will be linear because if you notice, it's following a linear pattern, okay? Versus a nonlinear. Nonlinear has to curve, okay? The points have to curve or they have to turn. Versus they're going in a, straight line direction. And that's what's going on here. C, describe the correlation between the scores and the hours studied. Well, obviously, the more hours you study, the higher your test score. Okay, if you notice, if you study 1 hour, you're looking almost at 45 for your score. If you study 3 hours, you're looking at somewhere between 60 and 70 and 68 or something like that. Okay, if you study 5 hours, you're looking at 80. Obviously, if you keep studying more hours, your score will most likely be a little bit higher based on the scatter plot. Okay, so the relationship is the more you study, the higher your test score. Okay. There are 2 assignments that you're going to do in IXL and a SchoolNet. I know it seems like a lot. Your SchoolNet is probably going to take maybe, I want to say, less than 5 minutes, probably even 3 minutes. And then your SchoolNet will probably take you about 5 to 6 minutes, even less. Okay, it's super easy. All they're going to ask you is the following scatter plot positive or negative? The scatter plot, is it linear or non-linear, and so on. Okay, if you have any questions, just let me know.